So like I said, today and Wednesday, hopefully wrapping up our basic math review. Today we're going to talk about decimals. And we're not going to spend a lot of time with operations on decimals. I just want to talk a bit about the structure of decimals and doing some conversions with decimals. And then we'll move on to the next step. But the key to decimals, just like with our whole numbers, is that place value. So to review some of our place values here from the end of the number, working our way backwards. This last place value here is the ones. What comes next? Tens and hundreds. And as we mentioned, those three place values get repeated over and over again. And it's just in the base group and the thousands group and so on. What I want to do today is I'm going to write them out numerically. 100,000s, of course, looks like that. 10,000s, 1,000s, hundreds, tens, and ones. And as we look at those numerical values, we see a pattern. Every time we move one slot to the right, the value of that place value is divided by 10. 1,000 divided by 10 is 100. 100 divided by 10 is 10. 10 divided by 10 is 1. So as we continue onto the other side of the decimal point, that pattern also continues. 1 divided by 10 is 1/10. 1/10 divided by 10 is 1/100th. And so on. 1/1000th. 1/10,000th. And 100,000th. And as you look at those place values, you might be thinking, those look suspiciously like fractions, because that's what they are. They are just a standard way of writing fractions with denominators that have multiples of 10. So for example, if we have 0.84, which would be pronounced as 84 hundredths, it can actually be written as a fraction just like that. 84 hundredths, 84 over 100. And of course, we wouldn't leave it like that. We would reduce that, both of those numbers being divisible by 4. Here is 21 over 25. So the first step in being able to express a decimal into a fraction is just being able to pronounce it. For example, 0.0375 would be pronounced. You just read the number without the decimal point. That's 375. And then you name the place value of that last digit, the 10,000ths. So that would simply be 375 10,000ths. And of course, you would have to reduce that. Both of those numbers are divisible by 5. Both of them are divisible by 25 even. I'm going to make it easier on myself, and I'm going to divide them. They're both divisible by 125. It would be 3 over 80. So converting from decimal to fraction is fairly simple. You just simply have to pronounce the decimal. And like I said, it's just writing out the decimal digits, and then the denominator is the place value of that last digit. Now another little double check. I don't like to use a lot of gimmicks, but I'll show you one here. This has 1, 2, 3, 4 decimal places in it. My denominator, when I made it a fraction, had 4 zeros in it. Okay, so we're not, like I said, we're not going to spend a lot of time converting between decimals and fractions. We're not going to spend a lot of time doing operations with the decimals as well. I just want to show you a quick example. Like 5.28 plus 37.9. Just like with whole numbers, when we go to add or subtract, we can only combine things that have the same name. And that goes right down to the place value. The ones can only combine with other ones. tenths with other tenths, and so on. And the way we guarantee that, of course, what do we do when we set this up so that we can add those numbers? I heard somebody whisper it there. We line up the decimal points. In fact, we really should put a 0 in here so that those are both expressed as hundredths, so that they have the same name. So with those decimal points lined up, now we're guaranteed that we're going to combine, as long as we're lining up all of our columns, only things that have the same place value. So 8 hundredths and 0 hundredths is 8 hundredths. 2 tenths and 9 tenths is 11, so it's 1, carry the 1. What do I have to remember to do before I can add these? Perfect, bring down the decimal. So 1, 5, and 7 is 13, so 3 carry the 1 and 4. Now I'm only going to show you one example of subtraction as well, but I'm going to show you a pretty intense one here. So 9 minus 2.8374. Just like addition, we have to line up the decimal point. Where's the decimal point on the 9? At the end of the number. Very good. If there's no decimal point written, it is assumed to be at the end of the number. Now, of course, we have to fill in the missing decimal places here to subtract. We have 0 minus 4, which can't be done, so we have to borrow. But there's nothing to borrow from here, so what do? We go all the way to the 9. We're going to borrow from the 9, making that an 8, which makes this a 10. But we need to get it all the way down here, so we have to keep borrowing. Borrowing from the 10 to make that a 9. This is a 10. Borrowing again, this is a 9, and now this is a 10. One more time, this is a 9, and this is now a 10. And now we can subtract. 10 minus 4, of course, 6. 9 minus 7, 2. 9 minus 3, 6. 9 minus 8, 1. And of course, before we do the 8 minus 2, we have to bring down the decimal, and then 8 times 2 is 16. 8 minus 2 is 6, not 16. 8 minus 2 is 6, sorry. Little hamster isn't completely on the wheel today. Again, just like I talked about with our whole numbers, I would hope you're looking at this and saying, hey, that's 9. This is really close to 3. 9 minus 3, I'm hoping to get something close to 6. So that gives me a reasonable answer. Okay, now for multiplication. We're going to do 5.23 times 3.8. I always put the number with the most digits on top. And now I'm going to multiply this completely ignoring the decimals. 8 times 4, or 8 times 3 is 8 times 3 is 24, so 4 carry the 2. 8 times 2, 8 times 2 is 16, so plus 2 is 18, so 8, carry the 1. And 8 times 5, 40, so plus 1 is 41, so 1, carry over the 4. Now we've been taught you got to move over, you got to add a 0 here to move over a spot. I also put a line up here so that I know that the numbers I've carried, the numbers below the line are used. They're not new unless I put them above the line. So 3 times 3, 9, 3 times 2, 6, and 3 times 5, 15. So 5, carry the 1. And so we add 4 and 0 is 4. 8 and 9 is 17. So 7, carry the 1. 1, 1, and 6. 8, 4, and 5. 9, and the 1. Where's my decimal point go? 3 spots over. We know that because we count 1, 2, 3 decimal places in the problem. We have to start at the end of the number and count 1, 2, 3 decimal places in the answer. Now again, just like any of the other stuff we've done, you could look at this and say, hey, this is about 5. This is about 4. I'm expecting 5 times 4. I'm expecting something close to 20. And if you think about it that way, this is the only place that decimal point can go. It's the only place that makes any sense. Because 1.9 wouldn't make any sense, and 198 would not make any sense. So 19.874 is the only location of that decimal point that makes any sense to us. Okay, so then a quick division by decimals. So if we have 18.92 divided by 3.2, and I want this to the nearest thousandth. Well, how do we divide by a decimal? Well, the answer is we don't. What do we do so that we don't have to divide by a decimal? We've been taught you move that decimal point over and make that a 32. But when we do that, what else do we have to do? Move the other decimal point over. The reason we're able to do that is because division and fractions are very closely related. In fact, you can kind of flip back and forth between division and fractions. You put division into a fractional form. And if I wanted to get rid of the decimal point on the denominator of this fraction, which is the number I'm dividing by, it's got 1 decimal place, so I'm going to multiply by 10. Of course, if it had 2 decimal places, I would have multiplied by 100, and so on. So I multiply by 10 to make that a 32. Well, since this is a fraction, I have to do the same on top. Multiplying by 10 makes that 189.2. So this division now becomes 189.2 divided by 32. So, does 32 go into 1? No, so we leave it blank above the 1. Does 32 go into 18? No, so we'll leave it blank above the 18. Does 32 go into 189? Yes. 6 is just a little too big, so we're going to try 5. 5 times 2 is 10, so 0 carry the 1. 5 times 3 is 6, or 15 plus 1 is 16. So we subtract 9 and 2, 29 left. Now before we bring down this 2, what do we have to do? Move up the decimal point. Perfect. Now we can bring down the 2. 32 into 292. Let's try 9 times. 9 times 2 is 18. 9 times 3 is 27, plus 1 is 28. So we subtract, and we have 4. Now what do we do? Well, we can add a 0, and we can keep dividing here. We said we wanted it to the nearest thousandth. I'm only to the 10th so far. So I add a 0, and I bring it down. Does 32 go into 40? How many times? Once, right? So 32, we subtract to get 8. And we can add another 0 and bring it down. 32 goes into 80 how many times? Twice, good. 2 times 32 is 64. There's 16 left over. Now we're at the thousandths digit. Does that mean I can stop there? No, I'm going to add one more 0 and bring it down. It's 160. 32 actually goes into 160 exactly 5 times. So if we would have gone to the nearest 10,000th, it would have came out exact. But we wanted it to the nearest thousandth. So what this last digit tells us, we had 5.912. It's either going to stay 0.912 or it's going to have to round up to 0.913. The 5 tells us it's going to round up, 5.913. Any questions? All right, so that's all the time I wanted to spend on decimals with you. We looked at taking a decimal into a fraction, I want to look now at changing a fraction into a decimal. We'll start out with one that we all know. Of course, we know 3/4 is going to be 0.75. But let's look at how we would calculate that if we didn't know it. We would do numerator divided by denominator. 3 divided by 4. Now, of course, 4 does not go into 3, so we leave it blank above the 3. There's nothing after that, so we could add zeros, but we can only add zeros after the decimal point. So we got to put our decimal point in, and now we can add zeros. 4 goes into 30. How many times? Goes in 7 times. 7 times 4 is 28. That's 2. And we keep adding zeros. Add another 0. 4 goes into 20 exactly 5 times. So it's 0.75, as we said. Okay, so the biggest thing with decimals to deal with is powers and roots. For example, 0.3 squared. Without punching in your calculator, is the answer 0.9? Say no. No, it's not. 0.3 squared, of course, is 0.3 times 0.3. 3 times 3 is 9, but we have a total of 2 decimal places in the problem. We have to have 2 decimal places in the answer. It is 0.09. When we multiply, I'm going to go to whole numbers here for just a second. 8 times 2 is 16. That gets larger from 8 to 16 because what we're multiplying by here is larger than 1. But if we multiplied by 1, 8 times 1, of course, is 8. When we multiply by 1, the value stays the same. We're so used to when we multiply getting something that's bigger. But if we multiply, let's say 8 times 0.5, well, 8 times 0.5 is 4. Because we multiplied by something smaller than 1, we get a result that is smaller than what we start with. Well, when we take a decimal to a power, we are multiplying by something smaller than 1. So if I have 0.12 to the power of 3, first, can you tell me how many decimal places am I expecting this to have? Six. Perfect. 1, 2, 3, 4, 5, 6. Now, 0.12 to the third power, 12 to the third power is 1,728. Have to fill in the zeros. And the calculator will confirm that. Now, a lot of times your calculator is going to kick this into scientific notation. And scientific notation is something we will talk about either Wednesday or Friday of this week. The other side of it that's really easy to get stuck on then is the square root. It's real easy to jump in and say, oh, the square root of 0.9 has to be 0.3. But again, that's not correct. 0.3 squared is 0.09. 0.9, the square root of 0.9 is going to be an ugly decimal. There you go, 0.9498. When we take the square root of something smaller than 1, the number should actually get larger. For example, if I take the square root of 0.04, I should get a significantly larger number. Should come out to be 0.2. just so you guys know, for the test, I won't be asking you to do any powers or roots without a calculator, but I will be asking you to multiply, divide, add, and subtract decimals and fractions and whole numbers without the calculator. Remember, the first half of the first test is without the calculator. In the second half, you can use the calculator. Okay, so now on to the next step. What if we have problems that look like this? Looking at this problem, there are several different ways we could interpret it. Somebody might look at it and say, hey, we read from left to right, so I'm just going to do the problem from left to right. Now, don't write this down because it's not going to be correct. Go ahead and do, well, 8 plus 3 is 11. 11 times 7. Oops, I don't know why that came in 7 there. 11 times 7 is 77. And 77 minus 9 is 68. And that process makes perfect sense. You go left to right, just like reading a book. But it isn't the correct answer. There are a lot of different ways you could look at that and interpret it, and it would make sense. But in math, we tend to like to have two people do a problem and get the same answer. So to guarantee that everybody would get the same answer if they do that problem correctly, we've defined something called the order of operations. Now, a lot of people think of the order of operations as being a set of steps, and that's not really true. The order of operations really define levels of priority. Higher priority items have to happen first. So our first level of priority is something called enclosing symbols. Now, a lot of us have been taught that is parentheses. That's one type of enclosing symbol. But there are several other types of enclosing symbols that we'll run into. Second level of priority is exponents. Exponents include what we've just talked about, powers and roots. Our third level of priority is multiplication. And as we've said, multiplication and division are the same operation, so division is included in there as well. And finally, lowest priority. It only gets done if there's nothing else to do to the numbers, is addition. And since subtraction is part of addition, that gets included here as well. Addition and subtraction. So back to this problem here. There are no enclosing symbols and there are no exponents, but we do have multiplication. So that tells us the first thing that should be done is the multiplication. 3 times 7 makes what? 21. Good. So now we have only addition and subtraction. And when we have more than one at the same level of priority, then we do work left to right. So 8 plus 21 is 29. 29 minus 9 is 20. So the correct answer to that problem is 20. Very different than the 68 we had before. So let's look at examples that are a little bit more complex than this. Bless you. Okay, so looking at something like this. First level of priority, of course, is enclosing symbols. And we actually have several enclosing symbols here. When we have more than one, we go right or left to right. So going left to right, here is our first parenthesis. So the first thing we have to do is find its other end. That's all the way over here. So we start working inside that set of parentheses. I'll refer to it as the purple box. Inside that purple box now, our order of operations still applies. So we still look for through our levels of priority. Inside that purple box, are there any other enclosing symbols? Yes, there's two of them. So we go left to right again. Here's our first set of enclosing symbols. So we're inside that parentheses. Inside there, are there any other enclosing symbols? No. Are there any exponents? Yes, there's 2 to the power of 4. What is 2 to the 4th power? Two to the 4th power is 16. So I take out the 2 to the 4th power, and I replace it with 16. The rest of the problem does not change. So I'm still working inside that set of parentheses there, inside the green box. All that's left to do is 32 divided by 16, so I'm going to do it. It gives me a 2. Once again, the rest of the problem remains totally unchanged. Now, I've reduced what's in that set of parentheses to a single number, so I don't need the parentheses anymore. So I can take them out. Now I'm going to cheat and I'm just going to erase them. I do have to check when I take them out, is there an operation on each side of the parentheses? And in this case there was, so I can go ahead and just take out those parentheses. Now we're back out to this larger set of parentheses that we had found before. Again, we'll call it the purple box. In that, are there any other enclosing symbols? Oh yes, there are. There's this one right here. This set of parentheses. So now we focus working inside there. Inside there, there's no other enclosing symbols. There are no exponents. So we are down to multiplication and division. We do have a 5 times 4, which is 20. So we take out the 5 times 4 and replace it with 20. Notice everything else stays the same. Now I get asked a lot, is this 5 times 4 or is it a negative 5 times 4? You could treat it as a negative 5 times 4, but then you'd have to change this from 18 minus 5 times 4. You'd change it to 18 plus a negative 5 times 4 like that. So if you made that change, it could be thought of as a negative 5 times 4, but this is now addition here instead of subtraction. So to me, it's easiest just to do 5 times 4 and leave it as subtraction. So now we're still working inside that parentheses. 18 minus 20 is 2, or negative 2, I should say. So we're down to a negative 2. Now, we're down to a single number inside the parentheses, so I don't need them as an enclosing symbol. But I'm going to leave them there for now, because that's a negative 2, which will bring us to another use of parentheses. In this case, it's not really an enclosing symbol. It's not telling us to do anything there. It's just a separator. It's separating that negative 2 from the rest of the problem, so we know that's a negative 2 and not subtracting 2. So that is no longer an enclosing symbol, so we're back out to this parentheses, or our purple box. And we go through it. There is no multiplication or division, so we're just going to go left to right. 12 minus 2 is 10. We have 10 plus negative 2 is 8. And we have 8 minus 3 is 5. Now we're down to a single number there, so I don't need the parentheses anymore. But as I mentioned up above, I do have to check to see that there's an operation on each side. There was subtraction here, but there was no operation here. What operation is implied here? It's implied to be multiplication when there's a number outside the parentheses with no operation. So when we take out the parentheses, we have to put in that multiplication. So now there's no more enclosing symbols. There's also no more exponents, so we can strictly do multiplication and division left to right. First one is 5 times 5, it's 25. Next we have the 5 times 6, which is 30. And now all we have left is addition and subtraction, so we will work left to right. 8 plus 25 is 33. Minus 30 is 3. We get an answer of 3. Now I will let you off the hook. If you have a scientific calculator, and if you do carefully type this whole problem in, it will give you the correct answer. The scientific calculator will do order of operations correctly. Now, the single most common mistake I see on a problem like this, and I guarantee you I'll catch at least one of you on the test doing this, is they'll look at this and say, oh, we got 8 plus 15 up front. I'm just going to make that 13. That cannot be done. Because if you look at the 5 here, the 5 has 2 operations, one in front of it, one after it. It has the addition in front of it. But after it, what operation is here? That's multiplication between the 5. Perfect, multiplication. Which one has to happen first, addition or multiplication? Multiplication. So we cannot add the 5 to the 8 until we've multiplied by whatever we have inside that parentheses. So don't get caught in that. Like I said, I will catch at least one of you doing that on the test. Don't let it be you. Okay, so that was kind of a long version of a problem, but had most of everything that we had in our levels of priority in it. Let's look at another version of a different type of enclosing symbol. We might have something like this. 5 times 7 plus 26 divided by 2 over 3 plus 2 let's see here. Times 7 minus 2 squared. We'll do like that. Looking at this one here, the first thing we have to do, get rid of my stray marks is the first thing. First thing we have to do is we have to decide, what does this line across here mean? What's it mean? Divide. Okay, it does mean divide. It is called a fraction bar. And it is telling us to divide. And it is also an enclosing symbol. It separates everything on top from everything on bottom. So it's telling us we have to do everything on top first, then everything on bottom, and then divide. Now on your calculator, if you're trying to do this, it's really difficult, unless you're very careful. It's really difficult to enter this all as one problem. If you're trying to do it all at once, you'd have to add parentheses here and here. The simplest way to do it on your calculator is probably just to do everything on top first, get an answer, do everything on bottom first, next, and get an answer, then just divide those two results. So if we're doing it by hand, what do we have to do first on the top here? Help me out. Multiply. 5 times 7 is 35. Very good. What would come next? Good. 26 divided by 2 is 13. And then we just add. 35 plus 13 is 48. So the top of this becomes 48. On bottom, what do we do first? Parentheses. And in the parentheses, we have to 2 squared, which is 4. What's next? Yep.
7 minus 4 is 3.
Perfect. 7 minus 4 is 3. I don't need the parentheses anymore, so I can get rid of them. What do I have to remember to do? Put in the multiplication. Good. What's next? Multiply. 2 times 3 is 6. And then add. 3 plus 6 is 9. 9 minus 1 is 8. This is 48 divided by 8, which is 6. So there's one last type of enclosing symbol I want to show you, and that looks like this. We're used to that square root symbol and you doing the square root symbol, but here it is acting as an enclosing symbol. It separates this part of the problem from the rest. So it's telling us we have to do what's inside there first. And inside of that, order of operations still applies. What do we have to do first inside that square root? Multiply. 9 times 7 is 63. So now all that's left is the 1 plus 63, which is 64. Good. Now, just like with our parentheses, we have it down to a single number in that enclosing symbol. So we don't need the enclosing symbol anymore. The difference is, with a square root, when we take away the enclosing symbol, we actually have to perform the operation. What is the square root of 64? 8. So we take out that square root symbol, we turn that into an 8. Now we had the 3 out front here. What do we have to put in here?
Multiplication.
Multiplication. Just like with the parentheses, that number in front of it with no symbol really implies multiplication. Now technically the square root of 64 could be 8 or negative 8, but we're only going to worry about the positive possibility for now. Our next step, 3 times 8 is 24. And 9 plus 24 is 33. Good job. Any questions? Okay. When we did our negatives, our integers, we talked about absolute value. And how we could have, this symbol here, absolute value of negative 12, is asking us how long is the vector for 12? Or how far from 0 is a negative 12? Well, that is how much? Absolute, there you go. Absolute value of negative 12 is 12. Well, that absolute value symbol can behave like another enclosing symbol. We could have something like this. So that absolute value symbol acts just like a parentheses. We have to do everything inside there first. So we'll do the 5 times 7 is 35. Oops, that's a 3 and an 8. Then we have to do 8 minus 35, which is 8 minus 35 can be thought of as 8 plus a negative 35. So positive 8, negative 35, that's going to be negative what? $27, or a difference between 8, there you go, negative 27. Now we're down to a single number inside the absolute value. We can get rid of it. Just like with the square root, though, when we get rid of the symbol, we have to do the operation. What is the absolute value of negative 27? Positive 27. Good. So now we have to put in the multiplication just like we do with parentheses or the square root. So then we have 3 times 27 is 81. And 6 plus 81 is 87. Okay, now like I said, that is a good share of our review of basic math. On Wednesday, we'll review percents, and we'll do the basic percents. We'll spend most of our time Do a percent increase and decrease, because that's really the difficult portion of percents. For now, we'll call it a day here. Out of your book, page 23, there's 1 through 21, the odds. And on page 29 through 32, it's 1 through 91, the odds. Now, as I said before, I don't expect you guys to do all these problems. I mean, this is what, 11 and 46, so that's 57 problems. I'm not expecting you to do all of them, especially on this one with the decimals. Do 1 or 2 of the easy ones and then skip ahead part way to the next section and just make sure you understand how to do them. The biggest thing with the decimals is make sure you are understanding how to do those calculations by hand. Because on that first test, there will be, like I said, first half of the test, you will not be allowed to use the calculator. Anybody have any questions? Okay, we will call her a day there. We will see you all on Wednesday.